Okay, let's give this a shot. Y plus 1 is equal to 2 sine of x minus pi over 3. So this is putting together everything we just learned here from 10.5 on translations, plus everything we learned a couple days ago, or yesterday actually, on amplification with that factor of 2 there. So let's go ahead and talk about that amplification. That 2 is playing the role of a, so the absolute value of 2, which is 2, is the amplification. The period of this sine wave is going to be 2 pi, because there is no b value being multiplied by x. Let's talk about the phase shift. Remember, the phase shift is affected by this x minus pi over 3. So what that does is it's pi over 3 to the right. And then this y plus 1, if you want to think about it this way, looks like we're going to have a vertical translation of 1 down. 1 down. So, the new origin, if you will be pi over 3, comma, negative 1. Pi over 3, comma, negative 1. So let's label our quadrantal value. So you know we're starting at pi over 3. We want to graph one full cycle. We'll start at pi over 3. Okay. Here's 1. Here's negative 1. I'll come down to negative 2 as well. So if the period is 2 pi, it's going to take an interval of 2 pi to complete one's full cycle. So add 2 pi to pi over 3, and you get 7 pi over 3. So we're going to complete one full cycle from pi over 3 to 7 pi over 3. Now, to determine your quadrantal values, again, just take the average. The average of pi over 3 and 7 pi over 3 is 4 pi over 3. This quadrantal value, take the average of pi over 3 and 4 pi over 3, and you get 5 pi over 6. And this last quadrantal value, take the average of 4 pi over 3 and 7 pi over 3, and you get 11 pi over 6. So my new origin, if you will, like we said, is pi over 3 over negative 1. So what might be helpful is for us to draw kind of a new x-axis. And maybe it would even be helpful to draw a new y-axis. So that's our new origin. Let's go ahead and graph this function. Now, it's a sine curve, okay? Now, remember, the amplitude is 2. So the sine curve starts with an output of 0, but we're at our new origin. And we're going to have an amplitude of 2. So from negative 1, we're going to go all the way up to 1, and as far down as negative 3. So I should probably label this down here, negative 3. So we're going to go up as far as negative 1 and as far down as negative 3. So the graph is going to look like this, gentlemen. There it is. That's one full cycle, starting at the new origin, which is pi over 3, negative 1, and it's going to end at 7 pi over 3. Okay, let's try another one here. Y equals 3 cosine 2x plus pi over 2. Now here's how I want to rewrite this so that everything is clear. I want to factor out that 2. So that becomes x plus pi over 4. The reason why I wanted to factor out that 2 is so that it's clear. That's A. That's B. Now remember, A is the amplitude that affects the verticality of the graph. 2, that's the value of B, which affects the period of the graph. So over here to the side, let's write everything that we need to know. The amplitude is going to be the absolute value of A, which in this case is 3. Our new period, remember from yesterday how we determined the new period, is going to be 1 over B times the old period of the cosine function, which is 2 pi. So in this case, B was 2, so it's going to be 1/2 times 2 pi. So our new period is going to be pi, okay? Phase shift is affected by this pi over 4. It looks like we're going to move pi over 4 units to the left. And then a vertical translation. There is none. There is no vertical translation. Okay, here we go. So first of all, since our amplification is, or amplitude is 3, we're going to go as high up as 3 and as far down as -3. Our new origin, if you will, is negative pi over 4. Negative pi over 4. And if we are going to complete one full cycle, it's going to take an interval of pi units to complete one full cycle. So if you started at negative pi over 4 and add pi to negative pi over 4, you get to 3 pi over 4. So from negative pi over 4 to 3 pi over 4, that's an interval that is pi units long. Okay, so let's find the quadrantal values. Smack dab in the middle. Take the average of negative pi over 4 and 3 pi over 4, and you get pi over 4. This quadrantal value in between negative pi over 4 and pi over 4 is 0. This quadrantal value in between pi over 4 and 3 pi over 4 is pi over 2. So now we are ready to graph, okay? So it's the cosine curve that we're graphing. And remember, the cosine, just your regular cosine function, starts at 0, 1. But in this case, since the amplitude is 3, and we're shifting to the left pi over 4 units, we're going to start up here at negative pi over 4, 3. And the graph, one full cycle, will look like this. There you have it. Okay? Let's try one more. A lot going on here. Y equals 5 sine of pi minus x over 2 plus 2. Right there, that looks different, doesn't it? So let's rewrite it. Let's rewrite it this way. As y equals 5 sine, and I'm going to do two things at once. We normally see the x term first, so I'm going to use a little bit of algebra to rewrite it this way, and I'm also going to factor out a negative 1/2. Okay? So it's y equals 5 sine, and then inside negative 1/2 times x minus pi over 2. If you were to distribute that negative 1/2 to the x minus pi over 2, you would get the same thing, pi minus x over 2 plus 2. And then I'm going to do one more thing. Recall that the sine function is odd, meaning the sine of negative x is equal to the opposite of the sine of x. So because the sine function is odd, and I've got that negative sign there, I can rewrite this function this way. I'll do it down here on the bottom. Y equals, and I can bring the negative out in front, minus 5 sine, and then this just becomes 1/2 x minus pi over 2 plus 2. So that in the end, that's what we're going to want to graph right there. So let's write down everything that we need to do over here to the left. The amplitude is the absolute value 5, which is 5. The period, since b is 1/2, is going to be 1/2 times the old period. So the new period is going to be 4 pi. The phase shift is going to be, sorry, this is wrong here. This should be 2 pi. The phase shift is 2 pi units to the right. 2 pi to the right. And then the vertical translation, we're going to go 2 units up. So the new origin is the way I like to think of it. If you're going to shift 2 pi to the right and 2 up, your new origin is going to be a 2 pi, comma, 2. Okay, so let me label this graph here. Okay, let me label this graph. So if we're going to start, and I'm going to try to do this to scale, but you know, we do our best. We're going to start it here at 2 pi. Since the period is 4 pi, we are going to complete a full cycle here at 6 pi. Quadrantal values then become 4 pi, 3 pi, and 5 pi. So let me label the y-axis, okay? So, 1, 2, 3, 4, 5, 6, 7. There's 7. There's 1. Negative 1, negative 2, negative 3, negative 4, negative 5. So if you want to, like I mentioned earlier, we said our new origin is at 2 pi 2. If this is helpful, make sure you draw them in as dotted lines, okay? So there's your new origin. Your amplitude is 5. So from the x-axis, your new x-axis, you're going to go up 5, and that'll get me up to 7. And you're going to go down 5, and that'll get me as low down as negative 3. It's a sine curve which starts at the origin. Here's what the graph is going to look like. Okay? So one full cycle. The amplitude is 5. It's the it's the sine curve. It's going to look like this. Oh, and I'm sorry, forgot about the flip. So remember what that does is that flips about the x-axis. So normally we would start at the origin and go up, but now we're going to go down. So it goes like this. There you go, gentlemen. That's one full cycle of this sine curve, starting at the new origin, which is 2 pi 2.